get started.
All right, well, good morning, everyone. I'm Catherine Murphy. I'm the science coordinator for the Middle Rio Grande Endangered Species Collaborative Program. And I want to thank you for joining us during this very busy time of the year to kick off our new seminar series. We're very pleased to have Dr. Rob Dudley present today on the Population Monitoring Program for the Rio Grande Silvery Minnow. Rob works with the American Southwest Ichthyological Researchers, or ACER, and also with the Museum of Southwestern Biology at the University of New Mexico, but I'm sure everyone in attendance today is very familiar with him. Just a little background, he's served not only as a science advisor for the conservation and management of threatened and endangered native fishes for many of our collaborative program signatories, but he also served as a technical advisor for the U.S. Fish and Wildlife Service recovery team for the Rio Grande Silvery Minnow. So I'm sure that everyone will be very interested in what Rob has to say today. Just a little administrative information. We are recording this seminar. So we ask that you please mute your microphones until the end of the presentation. Feel free during the presentation to submit questions via the chat feature, and the program support team will monitor those questions, or you can save them and raise your hand during the question and answer session to follow. I would like to emphasize that your questions and the discussions that follow this presentation are just as important to us as the information being presented. And we encourage, during these seminars, we encourage active dialogue between speakers and participants. So without further delay, I'll pass it over to Rob. Thank you.
All right, thanks, Catherine, appreciate it. It's a pleasure to be here today. This is different. I've never had so many black and white texts, images for people. I see no one's faces, but that's okay. I know who you are, and it has been a pleasure working with everyone over the years. So I'll just have to imagine speaking into a crowd. Okay, so great to have everyone here. And today we're gonna go through the long-term population monitoring that was initiated in 1993 and taking the results up to 2020. All right, is that all coming through there, Catherine? We're good. All right. So before we get started, I'd like to acknowledge my co-authors, Stephen Platania, also of ACER and University of New Mexico, and Dr. Gary White, ACER and Colorado State University. So of course, the focus of today is going to be the Rio Grande Silvery Minnow. It was described in the mid-1800s during the Pacific Railroad surveys by Gerard. It was listed as federally endangered in 1994. So a little background. Historically, this species was found throughout the Rio Grande Basin, including the Rio Grande and Pecos. And it was there with a number of other species, some shown here. So these were all members of the same reproductive guild. They have drifting eggs, and you can see the list here. And the only one that managed to persist over time in the Rio Grande in New Mexico is the Rio Grande Silvery Minnow. The rest of these have been extirpated or are extinct. There's also an experimental population. We don't really think about too much, but it's worth thinking about. This is an important concept in conservation biology. They are here, and there's been attempts in other areas, but this greater than 95% range reduction is the primary reason they were listed as federally endangered. Okay, so for our study area, here we are in the middle Rio Grande, and it's bounded by a dam at the top and a reservoir at the bottom. There's 3 reaches, the longest of which is Santa Acacia, and then they get a little shorter as you move up, Isleta, Angostura. And we're not going to talk about Cochiti today. There's sampling issues up there, but they also were historically found in that area. So to the north, Cochiti Dam, large impoundment that really changed everything in the 70s when it was constructed. Silvery minnow were found about 100 kilometers actually upstream of this dam historically. After the dam, of course, they were thought to have been extirpated fairly quickly in those areas. And this actually marks the upper portion of the critical habitat, starting at the dam here. Then moving downstream, we've got Angus Diversion Dam. This is the first of a series of diversion dams, which before Cochiti weren't necessarily barriers to fish movement. After Cochiti, they were. But the primary purpose for these was to divert water for irrigation needs throughout the basin for farming. So here's the first. The second is Ichthyological Diversion Dam. It's quite a large dam that diverts on both sides of the river. This diversion during times of the year can take a substantial amount of water. So the flows sometimes are quite different in the Albuquerque area versus the, say, Los Lunas area. Then moving downstream, this is the final diversion dam found near Santa Acacia. So a little bit north of Socorro here. This one also diverting water. And then the terminus. So this is the right around, I don't know if you can see this cursor here, but right around in here is the southern terminus, the critical habitat. This is a nice sat photo showing kind of the turbid waters of the Rio Grande as they enter Elephant Butte Reservoir. You can see those sediments then dropping out as you go through the reservoir. And then you have your classic hypolimnetic, low temperature, low sediment water coming out at the bottom of Elephant Butte. So the same as what happened upstream at Cochiti happens again downstream at Elephant Butte. So historically, looking upstream here at Santa Acacia Diversion Dam, you can see a really wide river channel just upstream of the diversion, braided. You can imagine a lot of low velocity habitats, slow areas, and these are really important for early life phases of fish, not just silvery minnow, but a host of other species. And you can see by 2002, the dramatic decrease in the effective width of the river in this area. And as you can imagine, that has a lot of impacts on habitat for these fishes. So for our sampling sites, so we've been doing this a long time, started in 1993. These are some of the long-term sites, and it's been consistent over time. That's the importance with these long-term ecological monitoring programs. The consistency, not only the sites, but the methodologies. So the sites are, the sites are distributed in the 3 reaches, the most sites in Santa Acacia, and then a little fewer in Isleta and Angostura, approximately balanced with the amount of distance that there is between these diversion dams. Additional sites. So this is something new. It was initiated in 2017, and these sites are only sampled during April and October. The other sites, the long-term sites, are sampled every month from April through October, but these are more intensive sampling that just happens twice a year. And they're a little bit more stacked so that it gives us 10 sites per reach. So you got a little bit more sites to the Angostura reach, fewer to the Santa Acacia reach. Gives us 30 overall though, which you'll see later has an impact on when we compute statistics to look at densities. And along with those, we also have a series of replacement sites. So we lost all 30 or lose 10 from the Angostura reach. We have a series of replacement sites that we can go to. And when the river's dry in that area, and that's what I mean by lost, then we can go sample a potentially wet site at a different location. And then we also have within a site all the mesohabitats that we sample. So this is a typical kind of general schematic of the river, different sorts of habitats, runs, shoreline runs, backwaters pools, and shoreline pools. And we have a balanced sampling program that we followed over a long period of time. And we have essentially a quota system where we don't exceed certain sampling in certain habitats. The more rare habitats like backwaters and pools are limited to 2. Runs and shoreline pools are limited to 4. And then the remainder is made up in the shoreline habitats. And we do 2 different kinds of sampling. So there's 2 gears essentially. For the adults, it's a larger seine with a larger mesh. And for the smaller fish, for these larval individuals, it's a smaller seine with a fine mesh. We take 18 with the adult seine and 2 with the larval. 20 seine hauls per site. Mesohabitats are standardized, sampling similar across flows, meaning we're not in the middle of the river during high flows, we're on the peripheral edge. And we sample approximately the same area across these months, across the years, across the decades. Consistency is the key. So how have things changed? Well, there was a period of time when there was a prolonged drought that followed a period of relative higher water years, and it created a crisis. And out of that crisis, there were a number of lawsuits, but we also had the formation of the collaborative program, increased sampling efforts during that time. I mean, there was really the worry at that time that we were going to lose this species, not just next year or a couple years, but permanently. They weren't in the hatcheries. There's big problems. The river's drying. We can't find them. And there's a bit of panic. So we're out there at one point every 2 weeks monitoring, since it's changed since then. Well, subsequent to all of this, there was external review. This was the first, 2004 and 5. A bunch of experts came together and reviewed the science and came up with some new ideas on how maybe things could be monitored and maybe done differently, more intensively, more precisely. And then also more recently, these are just the reviews. There's been other series of reviews in between and after, but these are the ones that have had the most impact on the project design. And the most recent review, the 2015-16 one, resulted in increased sampling, those additional sites, the replacement sites, a number of other things that kind of went into this evolution. So one of the important things early on was looking at estimation versus monitoring. There was the concern maybe that the monitoring, looking at these densities uncorrected, were we really detecting meaningful trends? So was it a good index for what's going on in the population size? So you can see the estimated population size on the top from the population estimation program and the density on the bottom, this EX that we'll talk about later. And you can see these trends are really similar. Well, the interesting thing is the techniques were completely different. So the ones that I've just described with the staining. But with the population estimation, it was done completely at random. So all the sites were random, all the selection of habitats were random. It was fully enclosed, meaning that we took boxes out into the river, closed off habitats, and then depleted them with electrofissures multiple times to come up with really rock solid density values. And despite the differences in the methodologies, we found a really similar trend. So at the end of 4 years, it was actually a 2-year pilot. So with all these data taken together from 2006 through 2011, the most robust data being from 8 to 11. There was another review, 2012 early, and it came out saying that there was a reasonable precision and accuracy for both monitoring programs. And what this resulted in, and there were other different factors going on at the time, but the population estimation program was subsequently dropped in 2012. So we won't be talking about that one, but we're going to talk about these two. So the population monitoring, again, shown on the lower graph here, and on the upper, the site occupancy. Totally different ways of looking at things, and we'll talk about site occupancy later. But the trends are the same. They take a little longer to unfold with an occupancy metric, that you see this decline from 2008 to 2011. And it's much more robust data set for occupancy. We sample essentially the same sites multiple times in November, but we do it 4 times for occupancy, whereas we just do it once for these October metrics. Okay, so for the objectives, You can probably guess a lot of these already. We're looking at seasonal and annual trends in the occurrence and density of native and non-native fishes, but with a strong focus on silvery minnow. And then looking at how these things affect things like water, timing, magnitude, duration of different flows in the spring and summer. How does that affect our population metrics? So classic ecology here. And then looking at the long-term densities across these individual mesohabitats. That was a suggestion of one of the review panels, just to see if these things track together reasonably. Also looking at relative and rank abundance of the different fish species, and then looking at this occupancy data set, which allows us to look at the variance in our estimates in November across days, but also allows us to compute this site occupancy metric. Okay, so here's the clock of silvery minnow going around through the year. Starting out in the early spring here, these are the adults coming in from the prior year, presumably going to spawn. They don't live very long, 1 to 2 years mostly, and then spawning eggs in April, late April through early June seems to be the kind of window there. The larvae then present during the summer months, and then the juveniles more towards the fall. And then the process repeats itself over time. So here's another nice schematic just to kind of show the general idea. In a spring flow, that's the story. That is the story for this species. High flows in the spring, and it's all timed to it. Eggs, larvae, and then juvenile through the fall. And these floodplain habitats are incredibly important in terms of nursery areas for silvery minnows. This is kind of the long term, how do things look from 1895 to 2017, but we'll look a little more recently how the spring runoff has unfolded. And so pretty good. 2019, bimodal, which is weird, but exceeded the long-term average. This long-term average actually just post-Coach D. It's going to be a little more realistic. 2020, completely different. As you can see, I mean, if you just look at the San Marcial comparison down here, no runoff at all in 2020. Really striking, actually. I mean, it was a striking year in so many ways. The flows didn't disappoint. What do we find? Not much. Larval fish didn't do well at all. We detected them in a few the reaches, but in very low numbers. And that then spilled over into the age 0 fish. So these would be the juvenile that we're collecting with the larger seine. We find them in a few reaches, extremely low densities. So recruitment failure in 2020. And what saved it? 2019. So the fish coming in. So what we can see here, the fish coming in from 2019 are shown in aqua. The fish in 2020 that respond are shown in blue. Just to confuse you even more, there's a red bar under here. If you're curious, those are the fish that are stocked. So on these years when there's going to be low numbers, somebody have a stocking program that puts fish into the river. But what we see is that the population was kind of bolstered really by the 2019, the spawn of 2019. And by 2020, these numbers were quite low. Again, shown here pretty dramatically. So we're robust, really dynamic amount of spawning and recruitment going on here in 2019, and then just a failure in 2020. So what's happened recently? So I'm a little bit excited to share some recent data with you as well. 2020 has been a little while ago, so I did some recent work to put the 2021 together. And so you can see things are a little better. So I don't want to leave a complete gloom and doom. A little bit of spring runoff. It's relatively weak. You can see it's not up to the green. But compared to 2020, much better. And you can see pretty dramatically here, we come in with extraordinary low numbers in the spring. So these surveys are really important. In the April, May, we get kind of a runoff survey of what's the spawning population, how many fish are out there, what's going on with these stock fish that we put in the fall, and then rapidly into what's going on with spawning and what's going on with early recruitment. So by July, things looked a lot better, not nearly like 2019, but better. And things we'll just have to see how we end up. It all depends on the flows in August, September, October. Okay, so we have some messy data. When things get dry, as they did in 2020, we have a lot of zeros. A lot of sites, there's no fish that were detected. We got zeros in the data set. It causes a lot of problems. If you're trying to do parametric classical statistical analysis, this is kind of a dramatic example of what you'd see: a lot of zeros, a lot of low values, just a few high values of densities. You really want something more like this green. We just don't, we don't get that. We don't get it for silvery minnow, interestingly, we don't get it for many other taxa. This is kind of a common thing for many of the fish, particularly if they go through any low density years. So what we come up with is a robust solution. It's actually fairly simple. It employs two different parameters. You have to keep these in mind. So we have a logistic model for occurrence, which is delta, shown here. This is just presence absence. Pretty straightforward, a logistic model to capture that. And then we got a log normal model. So anytime there's fish present, we can take those present values. So now we're ignoring the zeros here. The zeros are counted for on the logistic, they're ignored on the log normal. We can take the log normal and then come up with essentially a pure density value. So that's what we're looking for, is occurrence and density. So we'll talk about these a little more. So what's gone on recently? Up to 2020, we had really high values for both in 2019 and a pretty dramatic decline. Quite dramatic, actually, for delta values. We lost fish, they're almost ubiquitous. 2019, we'll find in less than 20% of the sites by 2020, and also a decline in the density. Now, interestingly, you see these lines are more or less matching up, but they're not entirely matching up. And that's where the cool part comes in later. We'll talk a little bit about the ecology. Since we're able to tease these two things apart, one thing that we can do is we can put it back together. So we get these estimates, and then we can put it back together, and we come up with a robust estimate of our density. It is based simply on delta and the mu, and then also this funny little symbol up here, which is just the variance of mu. It's just a standard deviation. So we account for all the variation here, and then also in our confidence intervals, and come up with a really robust. It's not nearly as pretty as if you just did if you just transform these using some simple, log +1 or something metric. You're going to get tighter error bars, but this is a more realistic way to compute these, considering all the variance that goes into what we're seeing here. And so here's what we have over the long term. Here's our EX values. So our density with our confidence intervals. So these are our 95%. So anytime the confidence intervals don't overlap, it means there's a statistically significant difference between the years. So a lot of differences across many years. They vary by orders of magnitude. That's what these little dotted lines are here. That's a lot. 2, 3, 4 orders of magnitude. I mean, that's the difference between 10 and 10,000. That's a huge difference. So I need to keep that in mind when you're looking at these graphs. These are massive differences across years. To kind of put that into perspective, this is what you might expect. They're a really high year. You might get 25 fish per haul. We're out there doing 400 hauls. That's an incredible value. We haven't actually hit that value yet. That's the 10 to the 2 up here. But on the low end, we have nearly hit that, which is 1 per 400 hauls. That's the limit of our detection. And to give you an idea, if we were to lower this one more notch, so we're 10 to the -2, to go down to 10 to the -3 we would have to take 4,000 seine hauls to be able to detect that low number of fish. So what you can see here is there's a dynamic range. It's enormous, but to detect fish at that level would take 10 times the effort that we're employing currently. So what happens over time? So if you look at these EX values compared to the flow, you see this interesting pattern emerge. And we noticed this in the early 2000s. It was really intriguing. It's kind of like, well, is that just, I don't know, fluke or what's going on here? But you see it go up in the high flow years and it's going down in the low flow years. And then it kind of repeats itself and it happens over and over again. Several decades later, it's a pretty strong pattern. And we see it again and again. In 2020 didn't disappoint. The values dropped as a function of the overall flow. Now we can get into a little bit more detail than just looking at a general graph like that. We can start to look at these parameters, start thinking things like the occurrence and the density. And we can start to tease apart these things and think a little bit more about the ecology. How are these things being affected by changes in the environment? Because they're being affected differentially. Because there's two different metrics. And we can look at these things over time and then start to build some models. And so what we did was construct a series of models actually using fairly straightforward statistics, since we've got nice values to deal with now from our mu and our delta, having transformed those. We can just look at those with classic GLM, these linear models, and just looking at single environmental covariates. So things like spring runoff conditions, estimated floodplain inundation, summer low flows. So we can compile all of these into our models. And then we allow a little wiggle room here, if you will, for these covariates. So we're not 100% sure, like when we say there's such and such inundation, or the flows were, whatever, over a certain number of days. There's not absolute certainty in there. And as we acknowledge the uncertainty in our EX values, these different models allow some uncertainty here too. So these random errors allow a little bit of wiggle room. It's not a straight interpretation, but we include both just to see, how they'll perform. And classic performance is evaluated with these classic metrics here, goodness of fit statistics, which are just your log likelihood and your AIC. We'll talk about those in a bit, but kind of helps just to look at these bivariate plots. So you can kind of see pretty much what I'm going to tell you in complicated statistic modes just by looking at patterns. And we'll kind of focus here now on the red dots. So that's 2020. And what you can see is the occurrence is very low, less than 20%. And you can also see that all these flow metrics are really low. We're down here at the really low peaks. No days when it exceeded 2000 CFS, basically no inundation, and a lot of days where the flows were really low. So that's what we're showing here in the bottom right. A lot of days where flows were less than 200 CFS or less than 100 CFS. And so what that results in is a loss of fish from these particular areas with really low flows. Results in river drying in some of these downstream areas, particularly. It also occurs and did occur in these letter reach, even at one of our sampling sites in 2020. That was the first, since we've been doing these replacements. But you also, of course, have substantial fish kills, depending on how long these areas are dry and the connectivity. So flipping modes, not thinking so much about the occurrence now, but just the density response. So this is kind of thinking more things like recruitment. The other is a little bit more like survival. And you can see here with the red dots, pretty much falls in line where you'd expect. It's all these low flows, and you subsequently get a low estimate of your mu in those areas. In those conditions. So like for 2020 is one of those years, these little cluster of dots that are near it are similar low flow years. And so that's in contrast to something like 2019 where you have overbanked flows, a lot of flooding, and you get a dynamic and really strong density response. Okay, so ecological model results. What floats to the top, so the density it's incredible, like I explained before. Varying over orders of magnitude. It's going to be as strong in the model no matter how it shakes out. Occurrence just goes from 0 to 1. But these density responses are varying over orders of magnitude. And they're really important for predicting these overall trends over time. And the fascinating thing is, so I've shown this graph many years, and we found this early on. And even between 20, I wasn't really sure, 2019, 2020, the really opposite ends of the scale, kind of things hold together. We found the exact same results in 2019 and 2020 for the top 3 models, no changes whatsoever. In fact, the weightings were almost identical. So we have a great stability in this modeling over time, telling us that there's these really important dynamic density responses to spring flows. And then on the flip side, it doesn't perform as well in the models, but for our delta models, we see a very consistent, actually explains a pretty good amount of the variation here too. If we're losing fish, so in other words, is the occurrence, are they not found at half the sites? Are they not found at 3/4 of the sites in October? That's really dependent on the summer flows. Are we losing fish from these sampling sites because of river drying? So we have 2 different phenomena happening here that we can kind of monitor. Now, something different. So with the 2015-2016 review, one of the interesting things that was brought up was, well, maybe you should look at dry sites and then not look at dry sites. Maybe if you didn't look at the dry sites and have all those zeros, you'd find something different. Maybe if you went back to you had 5 dry sites, maybe you should go back and sample 5 wet sites that are in the same reach. Maybe that'll be something different, but it wasn't. It was really interesting. When the fish are doing poorly, and some of this has to do with just how dramatically different the population size is across years. When they're doing poorly in a year like 2020, you go back and sample some of these other sites that are wet within the same reach, the fish are still doing poorly. So it's not dry, it's not a dry riverbed, which obviously has no fish, but it's a wet area, but it's been so, with this recruitment failure and things like that, we basically get the same result. So these red diamonds here, almost a perfect overlay on our blue dots, which are the blue being the classic 20 sites that I just described, and then the red diamond showing the dry sites being excluded. Totally different though. This is something new, and this was adding new sites, more sites. So going from 20 to 30. What's been the pattern? They're close. They're within the error bars. The estimates are similar. They're moving around a little bit, as you'd expect. These are different sites in different locations. They're also not weighted according to reach. We're stacking them heavily in the Angostura and Isleta reaches to get 30 per reach. But the interesting thing to focus on here is the width of these confidence intervals across time. So the confidence intervals with the additionals, so the 30 sites added, you see in every case, in 2020 being no exception, narrower confidence intervals. This is just what you'd expect. Realistically, I mean, if you had 60 sites, you had 120 sites, of course you're going to get narrower and narrower confidence intervals. You get more precision. But you always feel like you're getting a little closer to the truth as you sample more and more locations. So this was pretty interesting for 2020, the first time we've observed this. Between 2019 and 2020, with our classic 20 sites, we wouldn't be able to detect or to tell you that there's a statistically significant difference between those values. You can see the blue, the bars are overlapping. But with the red, they're not. What this tells us is 30 is actually pretty important. And it depends on, what level of precision you're looking for. Certainly when you get to low densities, the numbers of sites, it's been suggested going up to 50, it's been suggested going up to 100. There's certainly room here. It just depends on the comfort level and also the needs to detect differences at a certain level. But this is all just simple math statistics here. When you add more sites, you're going to get a more precise estimate almost no matter what. Okay, so also looking at mesohabitats, we want to see how these trends tracked over time. Just the long and the short of it, because we've already kind of beat these concepts to death, really similar. We go across these different mesohabitats, you see the same trends. There's a lot of gaps here and there, but the trends are similar, and you find a lot more fish in low velocity habitats. That gives us better confidence in these overall trends over time. You can kind of break these things apart and put them back together, and they tell you the same thing. And for these results, we found a really strong effect on mesohabitat, not surprisingly. Also within our model list was included reach, just kind of as a comparison, not nearly as strong. So across, what this is telling us is there's really big differences across backwaters and shoreline pools and shoreline runs versus Angus shore versus Santa Acacia versus Athleta over time. A different sort of analysis, we're looking at here the repeated data set where we go out 4 days in November and do the same thing over and over again. Again, say the same thing. So this pattern that goes over time, the ups and downs, the dramatic decline in 19 to 20. This is really interesting. This is held together so well. The only time that it kind of falls apart is when there's so few numbers of fish, like in 2013, that you're having troubles detecting them at sites. But even in 2020, detected all of the different sites, and the pattern's almost exactly the same. So different days, what are these? Well, you go out with the same people and you're sampling the same area. The flows are different, the turbidity levels are different. Sometimes there's pulses of flows that come through while we're doing our sampling. Fish are obviously moving around every day. They're not confined to this area, but we find the same thing. It's really fascinating. And then this kind of bodes well for our site occupancy as well. So in terms of the modeling, here again, we have the reach, in this case, being more important, the occasion being less. And then just quickly, we're going to go through some relative abundance of silvery minnow compared to other species. There's about 40 other fish species in the Rio Grande. Rio Grande silvery minnow is one of them. By 2020, it's less than 1/4%. Very low. Sometimes it's well over 50% of all this that's tax out there. It's just ubiquitous. So it has this really dynamic change over time. Here showing the rank abundances over time, sometimes being the least abundant of these focal taxa, sometimes being the most abundant. The other ones, interestingly enough, like red shiner or western mosquito fish, a lot more stable. So these fish, and it just goes back to their life history. They're a lot more tuned in, a lot more sensitive to these changes in river flows across years. Okay, so running out of time, and I'm going to grant myself 5 minutes. Okay, so site occupancy. We do the same methodologies, looking at these mesohabitats, and we go out every day, 4 days in a row to these different sites, and we mark those sites with these flags, and we come back and do the same thing the next day. And what that allows us to do is get a lot closer into, what is the true occurrence at this site? And we said it was less than 20% in 2020. But what really is it if you go out and do it 4 times? Because we know, and this is a kind of a famous quote from one of the ecology papers, few species are likely to be so evident. They'll always be detected when present. It's not just silvery minnow, but it's true all around. So you do this more robust sampling. And then we just use standard methodologies here for computing the occupancy probabilities, run it through program mark. And then we can compute these different metrics. Now, these are different. They're based on this sampling in November. It's repeated. And these things, they take longer to unfold because we're getting a more more accurate, actually, measure of how many sites are the silvery minnow located. What this is telling us over time is that early in the mid-2000s, found at most all the sites, and then slowly things start to erode down to 2013. Now we're down to the less than 20% of the sites occupied. This is like I say, a slow unraveling. It's also a serious indicator of something going very badly over time. It's a little more resilient to kind of these little up and downs. So 2020, things are down. They're not down as nearly as much as to indicate from just a simple occurrence metric. But the occupancy is lower, and it's quite a bit lower than it was in 2019. Something to keep an eye on. Again, the patterns pretty much the hydrology. These patterns are very comparable, as I kind of indicated before. And then you can look even a little deeper. The site occurrence or the site occupancy. It's made up of extinction, colonization, and these are basic concepts in conservation biology. It's also something really important to think about when you're thinking about an occupancy model. Essentially, you see these extinction values far exceeding your colonization. There's problems ahead. Colonization kind of catches up over time, and then extinction kind of goes back. So red on the top is a problem, black on the top is good. And you can kind of see that here with the different years. Again, kind of depends, and we'll have to kind of see how things unfold. For 2021, do we lose silvery minnow from even more sites than they were present last year? Or does this recent recruitment from the 2021 flow year reduce these? We get a little colonization, a little less extinction probabilities for 2021. Remains to be seen. So conclusions. Again, the big story, the dramatic decline from 2019 to 2020. High flows. So during spring, this is the most predictive thing for these increased density values. In contrast, the prolonged low flows during summer predictive of decreased occurrence, decreased occupancy. So these are both crucial factors. You can't have one without the other. Myopic focus on spring runoff or summer drying or what it's like, you kind of need both. You'd have recruitment, you need to keep those fish alive for a few years that you just that were just recruited from the year before. The trends are very similar, as I've expressed multiple times in the presentation here. Whether it's mesohabitat, repeated sampling, or occupancy, we find the same things. And then concerningly, so for, there's been a period of time, we lost silvery minnow from 85% of the occupied sites. And that's a robust measure of occupancy. That's a real problem. 2013, things got really bad. We don't want to go back there. But we're seeing a rapid deterioration in 2020. Need to keep an eye on things. Okay, so what are some little highlights? I'm going to feel a little better. What things can we do? Things already being done. Collaborative programs been doing these for decades in various forms. We'd always like things go a little faster, but we have to be patient. We are seeing some progress. Restoring dynamic river flows. What would I recommend? Restoring dynamic river flows. It's kind of going back to a historical condition, realizing you can't really go back there, but maybe you can bring elements of it. Reconnecting fragmented reaches, establishing a functional floodplain, just fundamental river ecology. Also, providing the spring spawning conditions, providing the summer survival conditions, both elements crucial. And then one that I touched on briefly in the beginning, talking about this experiment. This is actually really more important in some ways than a lot of these other things. To be able to really recover this fish over time, not to really recover, all the downlisting and delisting criteria. This is the thing. They have to get out. You have to get it out from here. I mean, you can measure this fish to death. You can figure out how many, few there are, how many more there are this year. you have to get them out of this area. You have to put them in different areas. Hopefully there'll be some initiatives and more success along these paths. And they've been lost from such a great extent of the range. You can't sustain them over time with a single population. And we see this again and again using the Middle Rio Grandism model. And then just monitoring these ongoing factors, not just us. There's lots of folks involved now doing lots of new modeling to look at the different population dynamics, looking at different things in different ways, looking at how we might need to increase our precision in our estimates by having increased monitoring sites. A lot of different things, and all these are helpful to kind of feed back into this loop of what we see. And so with that, I'd like to thank all the folks involved and to entertain your questions. Thank you so much.
Thank you very much, Rob. That was really great. I appreciate you putting this very complicated topic into simple and elegant terms, and also bringing in the management implications. I think that's very, very important. Before I open it up to questions, there were 2 questions submitted in the chat. So the first was from Joel Lusk with Reclamation. And Joel, feel free to jump in here if you want to follow up. He asks, how would you extrapolate the results of additional sites to the previous data set with 20 sites?
Well, basically, they're showing us the same trends. I mean, the weakness here is we only have a much lower number of years to compare between the two. But, you know, like I say, there's some subtleties to really think about there in terms of where these sites are located, because they're heavily stacked in the Angostura Reach versus the Santa Acacia Reach. So it'd be kind of difficult, I think, to make an apples to apples comparison between those two. Yeah, as opposed to if you just added 30, you know, if you just had 20 sites and you took 20 random sites, for instance, something like that, there are more to compare.
Thank you. Thanks. Okay, we had another question from Thomas Archdeacon. He says, hi, Rob. You mentioned the trends are similar, whether you're looking at mesohabitats, dry sites versus no dry sites, population estimation, et cetera. How do the trends compare to data from other programs using very different methods like fish rescue or the long-term genetics monitoring? Are they similar or different?
Oh, yeah, perfect. You know, that's a great question. You know, sometimes we live in our little bubble here, but there's a lot more going on. Certainly Fish and Wildlife Service has been doing long-term monitoring trends, really important throughout the area. Some of the areas that we don't sample because of access issues, things like that. And then a completely different way to look at things, looking at genetics. You know, you couldn't think of 2 metrics in some ways more removed from each other, at least tangibly, in how the data are collected. But yeah, they all marry together very well. We find these trends across time, whether it's fish rescue or whether it's genetic monitoring. These ups and downs they track. That makes us feel a lot better across program efforts, and it kind of reinforces the robust nature, not just of this program, but of the other simultaneous programs that are occurring long term as well. Thanks.
Okay, we have a question from Yasmin Najmi. She says, I'm curious about your thoughts on the differences in recruitment and conditions between 2017 and 2019, given that 2019, if I recall correctly, had a longer runoff and longer floodplain inundation.
Yeah, thanks, Yasmin. That's a really good one. I'm always glad when people really look at these graphs and think, yeah, what's going on? And I did the same thing, and it's a fascinating idea to think about that there's the year, which is important, but there's also the prior year. And I think really what we're seeing here in 2019 without this dynamic, because it was a little bit lower. It was lower than we would expect in 2019. We didn't get quite the response that we'd expect, because it was a great year. I mean, no question about it. It was an unbelievable year. And we still got recruitment. That's not to say it wasn't great. But what it does say is that 2018 was terrible. And so going into 2019, we're really already starting off on a bad foot for 2019. Going in with few fish, there was some stocking going on to try to supplement it, but it's really difficult to make up for those loss of fish just with stocking alone. And so I think that's really what was going on. Whereas between 2016 and 2017, things weren't nearly as dire in 2016 as they were in 18. So yeah, thank you.
Okay, we have a hand raised from Grace Haggerty.
Hey, Rob, really good presentation. As usual, you guys are, really stepping up and doing a lot of very interesting analysis now that I think is really useful. So let's go to 2021. It is a kind of nail-biting year for us, of course. I sort of was excited with the spring runoff. Of course, we were in Article 7, couldn't store water, had to let it go downstream. So this is somewhat not always going to be the case. Even though it was a low flow year, we still had some spring runoff, which is great. Didn't have a lot of inundation. But so it's really good to see that there was some recruitment. Looking back at some of your past data sets, are you guys starting to kind of predict what the October census might look like, or do you just kind of not do that? Just given the, I mean, I know we have had a little less drying, but of course, and MRGCD is going to be shutting off their irrigation October 1. But that still means September's there, to create some havoc for the fish potentially. So what are you thinking? I mean, have you looked at the curves in the past and kind of can predict what you're getting or what we might foresee?
Well, I haven't looked carefully to see exactly, where we think things might fall for 2021. And yeah, I love the way you put it together. And I appreciate the question. We don't usually try to predict in the future. It's so difficult. For one, just to get a handle on this hydrology, just month to month, and then going forward, what's going to unfold, we have no idea. But based on past years, so I'll give you a little prediction, not a full Bayesian model, but what we think is, and I know you're going to quote me on this because I was recorded. I don't think it's going to be as bad. I don't think it's going to be as bad as 2020. I think going in with that recruitment, we're seeing fish. The good thing with seeing them in July is that they've had a little chance to move around, maybe get out of some of these areas that are going to dry potentially later on. So I don't know, maybe just call me an optimist. That's what I'm hoping for 2021, is that we at least maintain the status quo or even a little better. But I completely agree. It was such gloom and doom going into the year. I remember Joel sending me graphs, other people sending me graphs on just how awful things were going to be. And then it was like, wow, there's water. And like you say, they knew there was some flexibility there. That's just incredibly important, though. What was, like you say, there's a lot of work goes into these things too. There's some luck too, but there's also a lot of work that went into these things, and it really makes an impact. And I really do hope that unfolds and kind of carries through the summer months into the fall. So.
One more quick question.
Sure.
It looks like La Nina is building up, so we don't know, of course. We're always surprised what the snow melt gives us. But what instances in the past have we had kind of 3 years of fairly dry? Like it looked like 2012, 2013 might have been kind of what we might be considering if it is another dry year.
Right.
What do you think about that?
Yeah, so you're right. I mean, if we hit into this series, what if it's not 3? What if it's 5? What if it's 7?
Yeah,
right. Yeah, exactly. It gets pretty dire. We have more tools in place now. I feel better about that. With the stocking program, it was going for sure. For sure. In 2012 through 2014, there was no lack of fish not being stocked in the river. Everything was, people were pulling all the stops out, trying to do everything possible. It's good that we got this recruitment this year. That's really valuable. It puts fish, and it's not just, and I always I kind of forget this stuff, but it's not just the numbers, but it's also, what we're seeing with alleles within populations, preserving these fish over time. It's incredibly important for the genetic diversity over time to have this, in addition to a hatchery, strong, robust hatchery program and all the great stuff that Tom and Megan have done over the years, but also, keeping these fish populations going through years. So, I guess I don't expect it to unfold quite as gloom and doom this year as it did quite rapidly in 2030. We just had just no spring runoff really for 3 years in a row. And so this one, I think it gives us a little breathing room, maybe for next year. The drying has it's varied for sure. But some of the areas that dry, they seem to be more or less the same locations. And so it dries in that area. We kind of get an idea of where it dries and lose fish. The spring recruitment is kind of the wild card. So that's kind of the hopeful there. So even if next year there's just a little bit of spring runoff that could be managed, that could keep it from diving down into these, site occupancy extinction scenarios like that unfolded in 2013.
Thank you.
Sure.
Thank you for that question, Grace. Does anyone else have any questions for Rob before I ask mine?
Sure.
Hey, I have a quick question.
Go ahead, Ari.
Thanks. I'm curious, since the 90s, we've seen tremendous narrowing through the river and colonization of bars and islands by vegetation. And I'm curious how you think that's impacted your sampling and if there's anything we can learn from that, because obviously through much of the, like Las Lunas, for example, we've got overbanking at much lower discharges, which should help the minnow if all of our models are correct. So I'm curious your thoughts about that.
Yeah, that's an interesting point, Ari. We do, like you say, we do get inundation at lower flows in some areas, and then in other areas, it's just really gone downhill. Santa Acacia Reach, I could remember being there in the mid-90s when Bosquedil Apache looked so different, so unbelievably different than it does today. We just don't find overbank inundation. There's work actually at that site to help with that at the moment. But some of the downstream areas from there, where it's become really incised, we just don't see it except at those exceptionally high flows. Upstream, we see a little bit more. Albuquerque has become worse, I would say, over time with the incision. And so I think that's an impact for sure. We're losing, I would say, overall over time, we're losing the kind of larval fish habitat across a consistent basis that we did back in the mid-90s versus now, which might give the fish a little more resiliency. I would guess in some of those areas, kind of like you're almost maybe hinting at here now, it's kind of an all or nothing. You got to get above this threshold before you really get an impact, then you really get an impact. So like 2017, 2019, that's great news. This population's been pretty battered, but it really still shows an unbelievable dynamic response up in some of those years. The more concerning part is on the lower end. Are we going to be able to see those siltings over time? And we won't really know this. It happens so slowly with such a dynamic nature of the fish. Or we end up in something where we're getting to essentially what I call lower highs and lower lows, where things just kind of trending a little downwards. Over time, it's been kind of this up, down, up, down, up, down. We really need to pay attention, though, if we start seeing, almost like Yasmin's hinting at, 2019. Well, so that's great. So what do you have? A couple of great years in a row, and we don't get this dynamic response again. Then we need to start really being more concerned. Yeah.
Thanks, Ari.
Thanks.
All right, any other questions while we pick Rob's brain? All right, well, I'm going to ask you an annoying question.
There are no annoying questions.
Oh, just wait. So this has been on my mind a lot in the last 8 months or so. And you and I have talked about this, but this population estimation program. So I believe it was done last time, 2011. And
correct.
We've had some interesting ups and downs since then. And at that time, the comparison was based on 4 years of data, correct? So what is your level of comfort, if you're comfortable saying so, about the relationship holding through time? And if you had to recommend, if we had, millions and millions of dollars at our disposal to throw at this, would you recommend doing that again? Or are you comfortable with where the population monitoring program is in terms of its evolution through time and it's sort of asymptoting out in terms of the changes that we need to make to it?
Yeah, so that's a great question. It's not annoying at all. It's interesting to think about these things, because there's never any easy answers to these sort of questions. But what I can say is that we felt pretty good. We felt pretty good in 2011. The program felt pretty good. The review panel felt pretty good. And it was kind of like, okay, we haven't gone through the dynamic ups and downs. We haven't, we got the high level. So in 8 and 9, those are pretty high. One of the highest, higher than we saw in 2019 and maybe 2017 even. And then we kind of got a mid-level and some things in between there for over those 4 years. We also got a low one in 2006, which we never really talk about, but it kind of showed the same thing. It felt pretty good that, these things are tracking reasonably well. And that was kind of the point. Long term, and so this is where it gets a little more complicated. Long term, I would expect the trends to be exactly the same, that they would match. We did, though, provide an analysis within the 2011 report to kind of look at how things might unfold, quote unquote, over time. It's using a power analysis. But really what we're looking at there is not so much like, will these things track over, so if it's a really high year, I'm certain that if you will go out and do an elaborate population estimate and a less elaborate than 30 sites or whatever monitoring program, you're going to find the same trends because they're so different across orders of magnitude. And if you go out in a really low year, and we never did this during the population estimate, but what would have happened if we'd done it in 2012? Always so curious. I think it wouldn't have been very good. We would have found, very few with our monitoring. We did find a few in the November surveys in September and things. And for the population estimate, it would have massive amount of work going through. And I'm very confident that we would have seen a dramatic decline in our population estimate in that year. But here's where the complicated part comes in. And that's that we're looking at confidence intervals. And so when we look at confidence intervals, if they're relatively broad, like you get when you monitor 20 sites, it doesn't matter whether those are 20 additional sites or 20 regular sites or 20 population estimate sites. They're still fairly broad. I kind of during the talk talked a little about, well, what happens if you get 30? getting a little bit better on your confidence intervals. And so that analysis, whether it's population estimation or monitoring, you're not going to get a close association between two metrics over time because the confidence intervals are broad. Now, if we did the monitoring at 100 sites and we did the population estimate at 100 sites, well, let me just tell you, doing a population estimate at 100 sites would have taken, let me think here, 5 times the effort. Would have taken 30 people every day in October. That's a lot of work. It took us 6 every day in October as it was, and it was a lot of work. But it was interesting, and it gave us, some measures. But the point is that if you don't have those numbers, population estimate, 20 sites, and you go down to these really low values like 20. What if we did the population? You have to have 60. You'd have to have 100. Who knows what you'd have to really kind of get a close metric. So kind of a long-winded explanation, but I would expect that you would find the same broad overall trends over time, but that to really get these high levels of precision, you just have to swamp it with a lot of sampling sites. I think it's a very robust metric. It's not without its faults, for sure. There's things that have been tweaked over the decades to make it better, but it's certainly not a population estimate. And on the other hand, to do a population estimate to get really high precision, you get what I just described, which is the millions of dollars scenario that you alluded to. So certainly there's ways to do things. Like in science, you can do anything. You can figure it out, you can do the models, you can run it, and you can test it, and you can see what happens. But my prediction would be that we'd find pretty much the same that we find not only with this monitoring program, but also with the genetics and with the long-term fish rescue, et cetera. So yeah, thanks. That's an interesting thing to think about.
Well, I appreciate that answer, and it really helps to put it in terms of cost benefit, because this is like #1 on people's minds right now. So I think that's very helpful. Were there any other questions from the gallery? All right, so I know we ran over an hour, but this was a rare opportunity, and I really appreciate Rob taking the time. And we can stop the recording now. We'll make this recording available on the program portal at a soon to be announced date. So Rob, we really appreciate you, and I'm sure we'll be following up with more questions later on.
Excellent. Well, thank you so much for hosting today. You did a great job, and really appreciate all the great questions today, everyone participating over the years, and just showing up to watch today. If you have any follow-up questions or anything, we're always available on the phone, email, whatever. So thank you very much.